be watching this anyway.
All right, commence.
Okay. So, hello everybody. To my knowledge, everyone here has completed a Python course last semester and is about to go into RTI 1121, where you will be learning Java. I would like to point out that the final class average for this course last year was a 57. I finished with a 98. So I'm able to get a pretty good idea of what everyone needs to know to succeed. As such, I've made a mini Java course that will equip everyone here with the fundamentals that you need to allow you to focus on the course content instead of stumbling over basics, because last year they did not pay any attention to basics at all. So with that, let's take a look at the agenda. I suspect that the use most of you will get from this session is just me explaining all the differences in syntax and thought process behind Python and Java. For example, you now have to worry about variable declaration and data types. There's lots of small stuff as well that the profs expect you to magically understand, like how you need semicolons at the end most lines and that you can't print an array just by putting it in a print statement anymore. I'll explain everything in time. But my ultimate goal here is to have everyone be able to do Lab 1 from last year with ease, because after reviewing my code for this course, Lab 1 is a pretty good filter to check which students understand the fundamentals and which ones do not. So if you struggle with Lab 1, keeping up is going to be very challenging. As such, I have written 4 questions that test the same knowledge that lab covered, and every subject I cover today will have relevance to it. I will not be covering the lab directly for fear of breaching academic integrity. So I've designed these questions to consolidate fundamentals more than challenge your ability to problem solve, so you can really focus on just nailing the syntax. Also, if you have not done so already, I recommend downloading this. Downloading this session over here. The link has just been posted on the chat so that you can follow along. I'm assuming the professors have gotten Java set up on your computers. If you have not done so yet, you may also follow along in an online compiler. So with that, I think we are ready to begin. So first thing I want to talk about is variables. Well, actually, are there any questions before we begin? Well, if there are any, just feel free to send a message anytime, and I will take a look. So the ultimate difference between Python and Java is that Java is not dynamically typed. This means that you now need to declare a type for every single variable you ever use. So back in Python, you might have been used to doing something like this. X is equal to 12, and then the compiler magically knows that you want to put a whole number into this variable x. And if you add a decimal point to it, like 0.5, it's just going to magically turn that into a double to store it accordingly. That does not happen in Java. In Java, the syntax for declaring a variable is you have a data type, you have the name of the variable, and then you have the thing that you want to assign to that variable. In this case, for this demonstration, I'm using integer here. Integer is just your integer from math. It's whole numbers and negative whole numbers. So we put 413 here, and then we can print this out just to see what it is. Let's do so. If I'm going too fast, please let me know. Like even if you don't understand like the commands I'm typing here, that's also something you could ask about, and I'll stop and explain that. So here we are. So yep, the number is 413 as we have assigned. And the number after adding 612 is 1025. We can also do this with plus equals. So if you see someone use the plus equals syntax, it's just number plus is equal to number plus whatever comes afterwards. We also have a bit of modulus. What modulus does is it just returns the remainder of this number divided by 10. So 1025 divided by 10, that leaves you with a remainder of 5. That is printed out here. And here is something interesting. When you have number is equal to number divided by 500, you'd expect to see some sort of decimal point afterwards. This is not the case because, again, the type we have declared for this variable is integer, so it can only support whole numbers. That means any decimal point that would have come after this just gets chopped off. It doesn't get rounded, it just gets chopped off. So that is the integer. And here we have a Boolean. A Boolean is just stores true or false value. In this case, we do number comparisons with double equals to check if an integer is directly equal to another one. Another demonstration of greater than or equals to, or just greater than or less than. All of that works. So that is how you compare numbers. Moving on to another data type, we have the double. Oh yeah, so integers, doubles, booleans, all the types I'm covering here, these will be used throughout the semester, but on the bright side, I don't remember any other ones being used. You can get through the entire course just by knowing integer, double, and string. So here we have double other number, which are declaring a new variable. This one is of type double, and what double does is that it stores decimal place. So it stores a decimal. So we put number in here. Other number is equal to other number plus 0.7. So number here back, this was 2.2. And then if we add 0.7, that works this time. It actually shows us with the double because the data type supports that. But here's where things get a bit interesting. If you try to put a double back into an integer, you need to specify that by doing something called a cast. Here I am putting integer in brackets. This means that I'm okay with converting double to integer before assigning. What happens when we try to do this without a cast is we end up with an error that says error incompatible types, possible loss conversion from double to integer. And the reason for this is because we're basically trying to store 2.7 in a data type that cannot support decimal points. So that 0.7 is going to be lost, and the compiler just wants to warn you that. So if you ever see that, just remember you need a downcast. And now it works again. Because another thing that might trip you up, even though other number is a double, so we know that it stores decimal places. So you'd think 15 divided by 4 would give you a decimal, and that would be put another number. That is not the case. As we see here, the decimal place got erased. And the reason for that is because both 15 and 4 are integers. And so it's going to try to perform integer division. And when that happens, we lose a decimal place. If you want to force it to do double division, you either cast one of these to a double or just use a double literal. As long as one of these is a double, the compiler is smart enough to go, okay, I need to actually worry about a decimal place, and it will give you that decimal place and avoid a bug down the line. There we go. Now we have the decimal place back. The last type I want to cover is string. String is, well, it's a bit different from the other ones because the data type is capital, first of all. And then we just like say, in quotations, BCD, this is the syntax of declaring a string. And printing that out, yep. We can also do string concatenation. So you take two strings and you put them together to make one bigger string. That we do with EFG here. That also works. Here we have char characters equal to A in single quotes. This is just the character, and then we can have the word is now equal to set character plus word, and now we have this string as A, B, C, D, E, F, G. So we have covered integers, doubles, and strings, and using these three data types, you can get through, I want to say 99% of the course. You only need to know how to manipulate these three primitive types, and you will be good to go. So that is variables. Are there any questions before I move on? I'm going to take that as a no. So in that case, I will hand it over to Glock to talk about scanner.
Hi, can you see my screen? Is my screen showing?
Yeah, all good.
Okay, so we're going to talk about the next topic, but before we do so, I would like to show you that I also got an A+ in ITI 1121, just like Glenn. So I know how to do well in this course and help you do well in this course as well. So let's talk about inputs. So how do you get the input from the user? And it's very simple. So all you have to do is do scanner input, then new scanner. So in Java, that's going to tell the compiler that we're taking in an input right now. And so this scanner will take in whatever is going to be put into the command prompt. So let's take a look at the first 3 lines. We're going to print out input a line. And then we initiate a string line, which is input dot next line. So this will take in a line of input. And then we're going to print out the line that we just put into the command prompt. So the line inputted is plus the line. So let me show you how this works. It's not running for some reason. Okay, that's very strange. Oh, I think because I haven't saved it. Yeah, that's right. So when you made a change, you need to save it before you compile it. Okay, so here it says input a line. Just type in hello, something, something, and then it says the line inputted is this line that we just put in. So are there any questions so far? Do you guys need time to copy this down? No? Okay, let's move on to the next example. The next one is input a number. So to get a number, all you have to do is use the method nextInt. So that's going to take in one number. And then we print out the number inputted is plus the number, right? So let's save this and then run this again. Yep, so as you can see at the bottom, I hope it's not too small, but it says input a number, let's put in 3, and it says the number inputted is 3. Are there any questions? No? Okay. Now let's take a look at the last example. So we want to get 2 words, input 2 words, and so you can just use the next method. So this next method will read the next string until the next white space. And then you do next again, so you're getting the 2 words, and then you print out the words inputted are, then you plus the first word, then the next word. Let's run this. So input 2 words, let's input the first word 1 and then 2. So as you can see, it's going to print out 1 and 2. And that's basically it for inputs. Okay, I'm going to give it back to Glenn.
Sorry, can you?
Oh, that's okay. I'll share my screen again. What's your question?
Can you explain how input next is scanning again?
This next method, you mean?
Yeah.
Yeah. So before I explain this, let's go back to this example. Here it says next line, right? So it's going to get the entire line. The next line means it's going to get the entire line. But the next method just takes in 1 word. It just takes in 1 word, and that's it.
So is that next pretty much means the scanner?
Yeah, it's scanning. It's scanning, right? Because the input, where does this input variable come from? Well, it comes from the scanner. So scanner input is equal to new scanner,
So
and you just type this in.
every time I have to declare scanner whatever equals new scanner bracket system.
Yeah, but you only need to do this once, right? You just need to do that once, and then you can use it as many times as you want. Right? You can see I'm using this 2 times.
So, but is it always in that form, or it changes like time by time?
It's going to be in this form, right?
Okay.
I mean, just input dot next. That's the way you write it.
Yeah,
So
but
does
like
that answer your question?
when declaring the input, like the one at the top.
Oh yeah.
Yeah, this one. Is it always like gonna be like this?
Yeah.
Okay.
Yeah. As for this one, the input, you can name it something else. So you can name it scanner. Right? It's just a name, so you can change whatever you want to. But
yeah, it's
for
just
this
like
one, this has to be scanner. Yeah.
Just still struggling with like the equal and new something. Like I've never done that before. So
I see. Yeah, so in Java, we work with objects, right? So just think of it as an object or a person who's going to scan things for you. So you're like, you're saying like, okay, let's get in a new person who's going to do the scanning for us. That's the way that I like to think about it.
And the system.n is, what does that do?
Yeah, that comes from the command prompt. So this is basically saying scanner is going to scan whatever the system is the command prompt, and then in, right? In is what goes into the command prompt.
Okay. So like the thing on the right side of equal is always going to be that, but the input, the scanner input, I can change it to like scanner, scan, or anything else.
Yep.
Okay, thank you.
Yeah. So scanner is an object, so you always have to say scanner, but this is the name, right? So you can change it to whatever you want. You can do scan, and that would be fine. That's just the name, but the object will always be scanner. This wouldn't change.
Okay.
Okay. So let's move on to the, oh wait, I think, yeah, that's right. Let's work on a simple Java program. So your task is to write a program that gets 3 integers from the user and calculates their average as a double. So this is a very easy exercise to do. I'm going to give you guys 3 minutes. Then after the 3 minutes, we're going to go over the solution. Okay, let's go over the solution. So the first thing you have to do is import a scanner. If you want to use a scanner, that's always something that you have to do. And then we have a class. And then you can call the class whatever you want. So Q1 solution, question 1 solution, and then you have your main method. So the first thing you want to do is create an input scanner. And then we say input 3 integers. Then the first one, int A, is input.nextInt. You can just do the nextInt method. And same for B, same for C. And then double average. So the average is equal to these 3 plus together divided by 3. And then we print out the average is this. So make sure that when you divide it, you do 3.0, right? So you're telling the compiler that you want it to be a double by putting in the 0.0. So if you do this, then it might think that it's an integer, right? Just to be safe, you can just do 0.0. Or you can also typecast it. So do like a double typecast. You can put in this, and that will turn it into a double. Okay, so let's run our program.
If you didn't.
So input 3 integers. Let's do 1, 2, and 3. So the average is 2.0, and this is correct. So are there any questions?
What does the class Q1 do?
It's just a name, right? So class Q1 is you're basically saying that this is the name of your program. which is Q1. You can see right here where I'm pointing my mouse at, it says q1.java. So that's basically the name of the file.
Oh, okay.
It really has no function other than saying what the name of the file is.
But do you need that?
No, it's up to you.
Oh, okay.
I got a quick question as well about the whole class thing up top.
Yes, go ahead.
Is so if you write public class and you have the name of the file and just writing class itself, does it make a difference when compiling it based off command prompt?
You mean like public class?
Yeah, does that make a difference when you're trying to compile it on command prompt? Or like I'm used to Java and like I'm used to using it in an IDE, and normally the IDEs put a public class in front of it. But like when you're doing it on command prompt, does it make a difference if you put public in front of it or not?
No, it's not going to make a difference. So I can run this program again. So I just put in public. I just saved it, and so it should be able to compile the new version now. Let's see. So input 3 integers 1, 2, 3. It's going to print out 2. So it makes 0 difference.
If I'm allowed to jump in, the questions about class are very good because it shows that you really want to understand everything that's going on in this program. However, the reason why they're very difficult to explain at the moment is because all of these class and public shenanigans, even the public static before the void main, all these pertain to object-oriented programming, which was Java's actual intended purpose. However, I want to focus on the basics for now because it's very difficult to cover object-oriented programming when we still need to go through variables and scanner. At the end of the session, if we have time, I can teach you guys a little bit about classes, so it might start making more sense of why we have to have class and then the class name as so-called boilerplate code at the moment. But for now, we should just treat Java programs as procedural programs, and void main is just your entry point into the code.
Yeah, so like when I learned Java, I look at this and I'm like, I don't understand what this means. But after I took ITI 1121, like this makes perfect sense. And you know what exactly the program does. So if you take away the static, if you take it away, then it has a different meaning to what the program is trying to do. But if you put it in the static, then it also has a different meaning. And this is something that we will discuss later on. Okay, so are there any questions? No questions. Okay, I'm going to give it back to Glenn.
Okay. So let us go back to the next topic, which is conditionals. So conditionals are your standard if-else statements, and really the reason why I'm pretty sure you guys have already done if-else statements in Python, so I'm just putting it here in Java to show you what the syntax is like. Instead of blocking things off with tabs, in Java we use curly braces. So an if-else tree might look something like this. You have your if, you have your condition brackets. If this is true, it's going to go in this block. If not, it's going to check if there's an else block here. In this case, there's an else if block. So if this is true, it's going to go in here. Otherwise, it's just going to go to the else block. And you don't have to have the entire thing all the time. This would also work just fine. You can also just have the if statement. And yeah, there you go. Honestly, this is pretty standard. I'm not even sure if I have to run it. If whatever expression here validates the true, it's going to go in. That is a standard if else. It doesn't have to be a Boolean. It can be something like if a variable I is equal to 10 or something. You get the idea. And alternatively, we also have a structure called the switch statement for controlling program flow. In this case, what the switch statement tries to do is it tries to match whatever you give it here with any of the cases. So in this case, I am taking an integer from the console, putting it, storing in this variable, and then putting that in the switch statement. So if this selection is equal to 1, it enters here, hits the break statement, and it exits the switch statement. It's 2, it goes in here, etc. And if it doesn't match 1, 2, or 3, it hits default, enters here, and then breaks. And let us run this just for posterity. Oh, whoops, not scanner. So, yep, flag A was true, and then that behaves as expected. 0.1, there you go. We don't pull any of these, it goes to invalid selection. One thing I want to point out about the switch case statement is you have to remember the breaks after the case. This is also kind of why I don't like switch case statements that much, because the syntax is really, really weird. But the reason they exist is because it is efficient at a really low level of the computer, so that's why they exist. So if you miss the break statement, it's going to hit case 1, it runs this statement, and it keeps going until it hits a break statement. So that is why you have both apple and banana printed. I'm taking a step back and realizing that it might seem this session is a bit all over the place because I'm learning about so many different specific things like this, and also remember to casting the double before doing division. The reason for this is because these are the bugs that I remember seeing just being absolutely rampant in last year's course. So I figured that it's a good idea to just cover them all at once and have them all in one place so that if you are coding and you happen to get stuck, you have this as reference material. When should we use switch? That is a good question because as I show down here, you can literally do the exact same thing with an if else statement. Switch, I find, is I don't know why, but in many of the labs and projects that I have experienced while taking Comp Sci U Ottawa, there is always going to be a question where you have to make a menu and then a menu of sorts, kind of like the apple, banana, cherry here. Sometimes you have to select a different function to run. That is when you use switch. It basically makes making a menu really clean. You can tell that you want the user to select something, and you do that with the switch case. It just makes your code a lot easier to manage. But if you don't like switch, I'm pretty sure you can just get away with using an if-else tree, and the professors probably won't take a mark off. But I have to mention it here just in case that they want you to use a switch statement. So here is this next red switch. You now have this at your disposal. So those are conditionals. Moving on from conditionals, we also have loops. And loops, we have for loops, while loops, do while loops, and all of these do the exact same thing. They print from 0 to 9. Pretty sure Python also has the same loops, so I can go through this pretty quickly. When you're declaring a for loop, the syntax is for, and then within brackets, you need to have 3 statements separated by semicolons. So the first statement here is an initializer. We just say int I is equal to 0. This runs once you enter the for loop. I is less than 10. This is the condition. Well, this is true. At each time execution reaches the end of the for loop, it's going to check if this is true. If it is, then it runs the update, which is the third statement, and then it heads back to the top and then enters the loop again. So as you see with its for loop, first it's 0. It's going to print out 0. And then it goes back to the top of the loop because 0 is less than 10. Gets add 1 to it, so then it prints out 1, and all the way up until you get to 10, in which case it breaks. While loop, it's basically the for loop, except you only have the condition. While this is true, when you hit the end of the loop, it is going to run again. Do while loops are while loops, but the one catch, it doesn't check the condition the first time it is run. For example, if j is, let's say, 20 before we start running the while loop, it's just going to skip this entirely. But for a do while loop, we have 20 here. It's going to run this once, and then it's going to realize that it doesn't need to repeat itself because k is already created. That is a do while loop. And we can just give that a quick run. And yep, you have 3 loops that all, oh, whoops, this one is 10. Well, I guess that goes to show how do while loops work. It runs the first time and then seeing that and then it just, the first time ignores the condition. So the first one's print from 0 to 9. Second one also prints 0 to 9. Yeah. Something also worth mentioning is that loops can also be nested. This is very handy for iterating through arrays or 2-dimensional arrays, as we will see later on. And here is just a small little program that I wrote to demonstrate how loops can be useful. If you want to calculate the factorial, let's say you want to calculate what is 9 factorial, we can do that with a loop. So starting from 1, we just say 1 is equal to 1 times the number after 1. So in this case, it's 1 times 2, and then we store 2 in factorial. And then what is 1 times 2 times 3? And then we store that in factorial, and so on and so forth until you end up with a factorial of 9. So those are loops. Are there any questions? Also, I realize I should probably, just in case people don't have Java installed on their system, I might as well show how we can run this in the online compiler, and it's the exact same thing. You basically have an entry point. Using that entry point, we can run some code. And there you go. It's the exact same output. Okay, if there's no more questions, that means we can move on to the next question of today, which is write a program that checks if a number given by the user is... Oh, is there much recursion in ITI 121? There was a little bit. So it's worth doing a bit of practice, like maybe just hop on Codebat and do a few questions once you actually get there. For those of us who don't know what recursion is, it's basically when a function calls itself. I will make a mention of it once we go over here, but for now, I just want to focus on this question. So there's a bit of recursion, but you don't have to worry about it too much. After all, anything you can do with recursion, you can also do with a while loop. It's not terribly fancy. But yeah, write a program that checks if a number given by the user is prime. And we'll give everybody 3 minutes to do that. Also, because I want to focus on syntax for this session, I don't mind if you guys search up the solution to this, because I realize that checking if a number is prime does involve a little bit of problem solving, but not terribly too much. It's mostly just to practice loops and get used to the syntax. Oh, another thing, if you are using the online compiler, something a bit unintuitive is what do you scan? You have to, whoop, you have to put whatever you want to put over here. That is just, oh. Right, I forgot to mention import statements. But yeah, if you want, each time you want to use scanner, you also have to include the statements. Have it. But yeah, that works.
Would you mind if I asked an object-oriented programming question based off imports, or like should I just hold on to it for a bit? Because I was just curious, like
that's the question.
because sure, so like you know how some specific compilers can like recognize that if you have another class in the package, it does, you don't necessarily need to import it into the file. But like if you're working based off like text editors, do you need to like write like import this this specific class into it so it recognizes that you can use that class if it's not in the same folder or something along? I don't know if
That's basically how it is, yeah. In order to answer this question, I basically have to talk about Java working directories. But for the most part, it's always safe to import, yeah.
Okay, that was good. Thank you.
Good question, man. Okay, time is up, so we might as well go over the solution. So, writing a program that checks if a number given by the user is prime. So naturally, we know that we want to check a number that is given by the user, so we declare a scanner. This is just boilerplate code for now, but all we know is that it's storing a scanner data type, and we could do things with this. So here we say input an integer. We store the next integer by the user in this variable called number, and basically what we do is we assume that the number is prime until we find a divisor. If we can find a divisor, we know that the number isn't prime, and we just set this flag to false, and then by the end of this, we check the flag. If it is true, then we know the number is prime, and it hasn't found a single divisor. If not, we know that it isn't prime. And this behaves exactly as expected. So we have a number 91. We know that that is not prime. We also have the number 13, and we know that. Wait a minute, what's going on here? Let me just fix that real quick. There we go. So I realized that the mistake I made is I was checking for factors well above the same number. So it probably the number saw itself, and I thought that that was a valid factor when it is not. So what I'm doing here is I am only checking up to the square root of that number for factors, and yeah, now it works. Are there any questions about the solution? Or the question? Okay, I'm taking that as a no. So in that case, we can move on to arrays, which will be covered by clock.
All right, I will share my screen. Can you see my screen?
Mhm.
Okay, so let's cover arrays in Java. It's not the same as lists in Python. It is a little bit different. So if you want to create an array, then you have to do int with this square bracket. So you're saying that's an array of integers. And then you name your array. So let's just call it array for now. And then it's equal to new int. And this array will have 5 numbers. It will contain 5 numbers. So when you initialize an array, this is what's going to happen in the compiler. So it will have an array of 5 numbers. And all of those numbers will be 0 by default. So they will be 0 by default. And here you say array at index 0 is 413. So basically you're changing the value at the first index to 413. So the first index is right here. So you're changing it to 413. And then array at index 2 is 612. So we're changing this to 612. And index 2 is right here. So 612. And you're changing index 4 to 1025. And index 4 is right here. So after these lines, then this is what our array looks like. Let me paste it below. Yeah. Okay, are there any questions? Make sure you understand this before we move on. Okay, no questions. Okay, so the next thing I want to talk about is printing arrays. Now in Python, you can just do something like print array and it's going to print you the entire array, but in Java, that's not the case. So let's see why. If you system out print line attempting to print an array, and then you print the array like this, it's not going to print out the content of the array. So let's run this program and see what happens. Okay, that's not what I wanted. That's gonna be Java arrays.java. Yeah, so as you can see, it says attempting to print an array, and then it prints out all of this stuff, which doesn't really make sense. But why? The question is why. So if this goes on a test, and the professor asks, why does it not print out the array, but it prints out a bunch of gibberish, like this one, then you can say that this is actually the memory location of your array. So that's just the memory location, the address. So if you want to print the content, then you need to do something else. You must use a loop, and for I is equal to 0 until the end of the array. So I is smaller than array.length. That's basically saying you go from the beginning to the end of the array. And then we're going to print out the array at index I. And then we just skip down a line. That's basically what it means. Let's see. As you can see, it prints out these numbers, just like what I predicted up here. So are there any questions? Does anyone have a question about the \t?
Is there any sort of shortcut to print arrays without using a loop?
Yes, there is, but you have to wait until you learn about like creating objects. There is a a method called what is it, toString. There's a method called toString, which you will learn later on in lab 5 or 6 or something. And that will basically allow you to print the array without ever using a loop. So what is the \t? Well, if you go on a new line like this, if you just go on a new line on your IDE and you press tab on your keyboard, so pressing tab, what happens here? Well, you see that it's creating an indentation, right? It just indents, and that's basically the same as pressing space for a few times. So the tab is the same as pressing a space a few times. So that's why you see it just puts a few spaces between these numbers. Okay. So let's see what this for loop does. Now here is our array at this point. That's our array. So what does this for loop do? Well, it starts at the beginning, it goes to the end of the array, and then it's going to set every index to 1,000. So after this for loop, this is what our array looks like. So it's 1,000, 1,000, 1,000, 1,000, 1,000. Yep. Let's test it. Yeah, I didn't really print it out. So here, let's print it out here. So there is a shortcut. You asked for a shortcut. So this is a shortcut, but you still have to use the for loop for this one. So this is more like the Python way of doing it. So int num in the array, and then you print out the number. Yep, as you can see, it prints out 1,000, 1,000, 1,000, 1,000, 1,000. And this is also a shorter way of writing the for loop in Java. Are there any questions?
What if I want to print like a single number from an array? Can I just like print array bracket the number?
That's a good question.
The row? Yeah.
Let's see. So this is our, okay, let's see. Okay, so since I comment this out, then we haven't really reset the array to 1,000. So what will our array be? It will be, let's see, 413, 0, 612, and then 0, 1,025. This will be our array at the moment because I commented these for loops out. So let's say you want to print this number here, 612. So system.out print line, then array at index 2, because this number is at index 2. So let's test it. Yep, prints out 612. Does that answer your question?
Yeah, thank you.
No worries. Okay.
I got another question really quickly.
Yes, please.
It's sort of based off like it's another random question. But when you're initializing an array, in the parameters for setting the size of it, could you have a variable there?
A variable like
if you
what?
put, so like int array equals new int, and then inside those double brackets, instead of 5, could you have like an integer array, like integer variable? Like let's say you have a variable that's been defined above it, like int a is equal to 5.
Oh,
and
I
then
see,
could you substitute a into that? And yeah.
like this?
Yeah, will that like
that
break
works.
it? That works?
Yeah.
Okay, cool.
Anything else? No? Okay. So we have one more example of a for loop. Oh, this does the same thing. Yeah, it just prints out the array and then skips down the line. So we covered this already. Well, let's go on to string arrays. So here is a little bit different from last time. Last time we did an int array, so an array of integers. Now we have an array of strings. So this is the way you do an array of strings. We put in Basil, Sunny, Aubrey, and Cal. And this is the same as writing it like this. So you can write it this way, or you can write it this way. They all do the same thing. So here you're saying we want a string array that has 4 strings in it. The first index will be Basil, the second index is Sunny, third index is Aubrey, and the fourth one is Cal. Okay, so make sure you understand this before we move on. So no questions? No? Okay. How about 2D arrays? Well, then you just do double brackets like this. The first number is 2, the second number is 3. So what does this mean? Well, it means that the first one is the row, the number of rows. This means there are 2 rows, 3 columns. Another way of doing it is like this. This means character. This means character. This is integer. So here we have a 2-dimensional array of characters where there are 2 rows and 3 columns. So you can do A, B, C, D, E, F. Now, what happens if we want to print a specific number inside this 2-dimensional array? Well, if we want to print out the array at 1, 1, so where is 1? 1 is here. So this is 0. That's row 0. This is row 1, right? So row 1 is here, and then column 1. Let's see, this would be column 1. Oh, I mean 0, and then this is column 1. So this will print out E. This thing will print out E right here. Okay. Yep, it's going to print out E. For each loops. For each loop is what I really showed you before. It's just a Python way of printing out arrays in Java. So it's very similar to Python. You do string name in the array of names, right? Because up here we declared a string array of names. So you declare string name in the array, and then you just print out the name, right? So this will print out all the content inside the array. Yep, Basil Sunny over Cal. And that is the same as this for loop. So this is more of the Java or the C++ way of doing it. So starting at the beginning to the end, and then you print out every index. So that concludes our topic for arrays. Are there any questions?
So both ways are fine.
Yeah.
Okay.
Oh, one thing I should mention for the for each loop, you cannot set the array using the for each loop. So we noticed that in the for each loop, we're going through the names and we have string name as the name we're currently printing out. If you try to assign something to that name, the compiler would not let you do that. If you want to set things in the array, you have to use the square brackets with the index. That is the only difference. For each loop is very nice for printing that.
Yeah, so what Glenn said is if you want to change the value of an index, let's say names at I is equal to something, right? 1,000, then you can only do it in the traditional for loop. You can't do it up here. If you do name is equal to 1,000, this will not work at all. So that's just something to keep out. Okay.
So which ones is more commonly used?
The upper one is more common for printing out stuff in the array, but the bottom one is for if you want to change the data, or you want to, let's say, go from the beginning to half the array, right? If you don't want to go the entire array, but you want to go half, so you divide by 2, right? But you can't really do it up here. This is more for just printing out the content of the array. So with that being said, I'm going to move on to the next topic and give it back to Glenn.
Okay, let's share my screen. Actually, there was one more. I guess. Oh yeah. Okay, so I guess we can move on to the third question, which is write a program that constructs a 10 by 10 array with each element equal to the product of its indices. So I'm just going to give you guys a few minutes to do this. If there are any questions, feel free to send them in the chat. feel free to continue working, but I'm just going to start commenting on a few things that I just thought of now. Remember, I noticed that there's some confusion about whenever we should use, when should I use a for each loop and when should I use a do switch over an if else. Something you'll notice with Java and also when you're learning more new languages as a whole is that sometimes in languages there are many different ways to do things, and everybody has a different opinion on which one is the right way to do it. So honestly, pick the one that you think you like more and just be consistent. That is the key. As long as you are consistent in the way you code, that's all that matters. So just use whichever one you like more whenever it seems like there's more than one way to do something.
How would you go about printing a 2D array? Would it be the same for each thing, or do you have to have another for each in it?
You would have to have. I recommend using a nested for loop for printing on a 2D array. I've never actually tried using a for each for a 2D array before. I guess that's because of my own personal preference, but I will give a hint for printing on a 2D array. Remember this? This iterates through all combinations of 0, 1, and 2 from the loops. So let's see, go back here. Wow, it's almost as if these look like they could be indices for accessing an array. But yeah, that is my hint for printing out a 2D array. If you want to get the length of the second array, well, I gave you the length for this one, it's just 10. Oh yeah, another thing? A question that I remember I had when I was starting out is I wonder why people use I in for loops all the time. Upon looking it up, I just stand for either index or iteration. So if that was bugging you, now you know. Ah, okay. So, time is up. Let us take a look at the solution for question 3. So the hardest part about this is you had to know how to iterate through a 2D array. I'm hoping most of you were able to at least declare the array. So we have the array declaration here. We have an integer, and then this is like an integer array. And then we have another array here to say that we want an array of integer arrays. And we say that this is a new array of a new 10 by 10 integer array. That is pretty standard. And now we have to figure out how to iterate through this. So we first traverse the rows using this for loop. So for int I is equal to 0, I is less than array.length. So this array here refers to the array of arrays. And then I++. Then we go through the columns. For int j is equal to 0, j is less than array. And then it doesn't really matter which one we pick. We just need to pick one of them. So we go for the first array in this area of arrays, and we use that length and j++. Honestly, if you just use 10 and 10, that's also perfectly fine. I'm just showing you a way that makes it a bit more dynamic, so it doesn't really matter which one. But yeah, this looks a bit ugly, but you just have to get used to it if you ever want to iterate through a 2D array. And then we assign this cell of the array to be the product of its indices, and we print it out. And what we end up with is something that looks like this. Because my command prompt is zoomed into hell and back, it looks a bit weird here, but copy pasting this gave me this output over here, which makes sense. So go from 0, well, 0, anything multiplied with 0, 0, that is why we end up with a row of zeros here. And then we have 1, 1 times 0, 0, 1 times 1 is 1, etc., and it goes all the way back and down until you had 81. That is how we iterate a 2D array. Are there any questions about this? I will take that as a no. And now we can move on to the last, I want to say, essential topic of Java, functions. So here we have a function, and yeah, it does what it says on the tin. Oh yeah, so basically the way we should think about functions for now is you put a static in front of the function you want to declare. Again, it's boilerplate code. You just have to do it for now. But basically, if you want a really abstract explanation, it means that this function is inherent to the class we declared in, and we don't need an object to declare, we don't need an instance to declare the function from. So just put static in front of everything for now, followed by the return type of the function. In this case, our function doesn't really need to print anything. We just want to call it, so we say void. Void means that the function doesn't have a return type. Then the double braces, and inside here, we put whatever inputs we want with the function. So again, for this one, we don't say anything. All that happens when we declare it is that it prints out a void. Let it look. Yep, there we go. So the first line that happens is this function gets called, and we confirm that it gets called. And now we can move on to a function that has an input and an output. So this function is taking a single integer as an input and giving you a single integer as an output. If you want more than one output, it's a bit hard to do in Java. There's no clean way to do it. Just think of all functions as being able to return one type. And we say that the function increment is called, and we return whatever number was passed in plus 1. And here we pass in 5, and then we print out whatever comes out right afterwards. If we really felt like it, we could do some like since x is equal to whatever the since x is equal to this increment and then print out x that have the exact same effect. But yep, this goes to yep, we get a 6 on the console, so that is working as expected. Now we have a bit more of a complicated function. So this one is swap. This returns a string array, and it takes a string array of words, the index of one index and another index. So this would be the index of the first word to swap. This would be the second. And that's exactly what we do. We swap these two words, and we return the new and we return the new array. So when we call swap with an array 1, 2, 3, and we want to swap the first element and the second element, that is exactly what happens. Printing out the array gives us 2, 1, 3. And moving on, we now have some. I just want to talk about overloaded functions for a second. So remember how we had a function with the name increment declared earlier? Java is smart enough to, if you have two functions with the same name but different inputs, Java will know which function to call, which is just pretty handy. And then whenever you do this, this function increment is now called an overloaded function, which is something that I am 90% sure the professors will ask you about on the test. So we have increment with two parameters called, and this version of increment just adds them together. So we have 5 and 10. This prints out 15, behaving as expected. The last interesting thing I want to cover about functions are the recursive ones. So here I have a function called Recursion Demo. This doesn't return anything, and it takes a single integer as input. If this integer happens to be greater than 10, we say return. If you have just return in a void statement, this is basically break. It basically means, okay, this function is done. Everything else is canceled. We're done here, and it doesn't do anything else. However, this means that if int iteration is less than 10, it's going to print out whatever iteration is, and then call the exact same function, so calling itself with that number plus 1. So what happens is that at start, it passes in 0, it calls recursive call 0, and then it just keeps calling it itself again with this adding up each time until you end up with 9, in which case we call recursion demo with 10, and then it happens to be greater than or equal to 10 now, so then it returns. That is basically bare bones of recursion. If you don't have this base case, you end up with getting what's called a stack overflow, in which case the function never stops calling itself, and then you just basically run out of resources because the function never stopped calling itself. So yeah, recursion, if you're doing any recursion, remember to actually have a way to break out of it. So yeah, those are basically all the things you can do with functions in Java, and they are your best bet for organizing code before you learn anything before you go into object-oriented programming. So with that, I think we are ready for the last question that I have for everybody, and this will test everything that we've learned up to this point. Write a function that takes an integer array, an integer value, and an integer index that returns a new integer array with the value inserted at the index specified. And all the remaining values get shifted down by 1. So you're going to be making a second array, and the second array is one size larger than the one you gave it, with the value inserted at index. This should be what your function declaration. So this should be what your function signature looks like. And I will give everybody 3 minutes to work on this as well. Assuming there aren't any questions. If there are any questions, just feel free to hit me up anytime.
I actually have a question. For when you're compiling on command, I see you write like both compiling it and like starting the program in a single line. What's the actual like line that you write? Because it's kind of tedious, right?
Yeah, that's a good question, and I probably should have gone through this. So basically, Java C means we want to compile something and then start our Java. This basically means that I am currently in the directory functions, right? So basically in this directory, I should probably actually show this in Explorer because you guys aren't using Atom. So we are in this directory. Calling Java C start our Java means that this is going to find every single Java file and make a class file from that. So this is basically how you compile a Java thing, a Java file. Then the next command I run is Java functions, and what this does is it basically it looks for the file functions.class. So whatever string you provide here, it's going to basically attach .class in it and look in this folder for that file. And then once it finds it, it's going to go into this file and then look for any function that matches public static void main. This is why this is like an entry point. If you call Java and then the class name, it's just going to run whatever's in main. So that is basically what's happening when I'm doing these commands. The double ampersand thing is a command prompt thing, and it basically allows me to run 2 commands in sequence. This is basically my workflow whenever I'm working on something big. So Java C, double ampersand, java.function, so I can do this, edit the file, press up and then enter again, and then just run it again. I don't use an IDE, and I probably won't unless I'm like modding Minecraft or something, because this works for me. But yeah, that is what I'm using to run this command. Does that answer your question?
Yeah, it does. Is there any other tricks like on command line that you can command prompt use this? Because like I'm new to it. Like I know Java, but I'm only used to it on an IDE. So like when the command prompt got introduced, I kind of got confused on how it can actually compile it and whatnot. So like, is there like a quicker way to actually get to this specific directory instead of writing in command line like dir and then clicking on desktop and then dir going to something else? Or like
I will show you how I get to these directories. So oftentimes you're able to at least get to the file where you want to go to, right? So I do Windows key for start to open run. I type in cmd, enter, and now I have a command prompt open to my UC directory. And then what I do is just kind of drag this in. And then, oh wait, I type cd, enter the directory, drag this in, and then now I'm in that directory I need to work in. Java C, start Java, double ampersand, Java, the name of the class I want to run, and okay. And there we are. So that is basically my workflow for using Java without a command, using Java without an IDE. That makes
Wait,
sense?
Glenn, there is one more way to do it.
Yeah.
Can I share my screen? I'll show you the way I do.
Sure. Maybe I'll learn something.
Yeah, so what I do is I just open up my file explorer, and let's say you want to go to the like the file where you put your Java code is. So the first thing is to go to that directory.
Oh, you just type cmd into the address bar.
Yeah, but like this is the way I do it. So okay, so here is where I put all of my code for this workshop. So I just copy it here. So you click here, you copy, and then you go to the command prompt. And actually, let's close it and reopen the command prompt so we can start fresh. And just type in cd and then you paste it, right? So I don't need to drag it in. Just click cd and then that's it. You can run your Java program. So yeah, I hope that helps.
Works fine if you don't like dragging things in, I guess. Okay, I have to say one last way now. If you don't want to even open command prompt using run, you could just go in here, address bar, cmd, enter, and then you're already in that folder. The reason I forgot to mention this one is because I bound it to a script so that each time I hit F8, it basically inputs that for me. But yeah, that is probably the fastest. Okay, enough about workflows. Let's move back to the question. So, write a function that takes an integer array, a value, an index, and insert it. So we're just writing a function that inserts the thing into an array. I think this was actually ripped directly from Lab 1, so this question might get asked in your class. I'm not careful, but we'll see. But this is my function for inserting something into an array. So first thing we need is an array that is one size larger, because when you declare an array, its size is static. You cannot make it bigger. You have to declare a new one with the size you want and then copy everything over. It's a whole pain. So we make a new array that is one size larger than the old array, and then we iterate through it. And I do everything in one pass. So if I is less than the index that we want to insert our new value at, we just copy in the old array's value. So the value at the new array is equal to the value from the old array. Otherwise, if I is equal to the index, we say that the new array at this index is equal to value. And now we have copied the value in. And then otherwise, we know that I is greater than the index, which means that we basically have to copy in the next value from the old array, but since I has already moved on by one, we see is equal to array is equal to I minus one. That is how we copy it in. And the only reason this looks a bit messy is because I remember copying it like just from my old labs code. So we have an example array and then something to the insertion index and the insertion value. We print out the array before insertion, and then we call this function and then print that out as well. Again, if there's any questions, even about whatever the heck is going on over here, please ask me. So here we have it. It works as expected. You have your array before insertion, it's 1544796, and then we want to insert at index 3, which is the fourth number. So we put 15 over here, and it all behaves as expected. Are there any questions?
Go over again
Nope.
how you, sorry,
Yeah.
yeah, can you go over again how you made the array a different length? Because I don't understand, because you said before how you couldn't
Okay,
change it.
so this is how we make the array a different length. Again, if you ever want to change the length of an array, the answer is you can't. You have to make a new array that is the size you want, and then copy everything from the old array into it. Here we have the integer new array. So I want this is the array that I'm going to be returning, and I know that the size of this array is the size of this old array, except with one bigger for the index that I want to insert this thing in. Remember that when you're declaring the size of an array, whatever goes in the square brackets here, that is the length of the array. So you can have a 20, 30, etc. What I am basically doing is I am getting the new size of the array I want by using array.length. So that is the old array size plus 1. That is a new length. And then we put this inside here. And the type matches, and that is happy. And now we have a new array with this size plus 1. So does that make sense?
Yeah, that makes sense.
Cool. But yeah, what you need to also remember is that this new array, even though we initialize it with this new size, it doesn't, all these values are 0. We have to copy everything else in again. That is this question in a nutshell. And if there aren't any questions, we have basically covered everything on the agenda. This question tested everything. It tested whether you can make it function, tested if you can declare, it tested if you can know how to declare an array, tested a loop, knowledge of loops, tested knowledge of conditionals. All of this means that you basically, within a method block, you can do anything in Java now, which is pretty good because you're going to need, this needs to be second nature by the time you start doing object-oriented programming.
What does
So,
%n do? Oh,
yeah?
can you go back?
Mhm.
What does %n do on line 28?
Line 28. Oh, yeah. So this is basically a really fancy print statement. The reason why it's even here is because, again, this is probably copy pasted from my solution to the actual lab. System.out.print format. So this is print line, this is a print format. What it does is %d means that it looks for a double. Wait, let me look this up actually. Basically, whenever you call printf, you can also pass in some values that will just get magically subbed in, which is just handy if you don't want to type, if you don't want to do a ton of string concatenation.
Well, yeah, I'm used to that from C, but I've never did %n before, so I'm just confused. Like, what does %n?
Oh, Percent n, yeah. Okay, so the percent n is just new line. So this basically, if you don't have this here, it basically doesn't do a new line at the end of it. So let me just do a quick demonstration. So this is with the percent n. And you see that there is a new line here and it prints it whatever this is. If we don't have this condition, it basically doesn't have a new line at that. And now, because that percent n was never there, the new line was never entered, and you just end up with the message directly afterwards. So I have the percent n there just so that this behaves like a print line. That makes sense?
Does backslash n also work, or it's just that?
Good question. I think so. Yeah, it also works. Percent n is just, you can only use it if there's printf. I guess I had a printf cheat sheet open and I just saw percent n and I went for that instead of backslash n. But yeah, both works. Again, back with what I was saying about these new languages, there's often many, many ways to do things. Doesn't matter which one you choose as long as you're consistent. The percent %d just looks for a number to sub this in. So I have two. So the first percent %d gets subbed in with insert value, the second with insert index. This would be the exact same as typing print line. Get rid of this. And already you can see that this looks disgusting. And that would be the exact same thing as that print statement. So it's basically a way of printing that doesn't breach the character line limit that you wanted. It's just less typing, I guess.
Yeah,
Yeah.
I'm more used to that than the print ln. So
Again, use whichever one you prefer. Printf is honestly the one that I should be using more because you don't have to concatenate as many strings and it's just less typing in general. I just grew up with print line and that's the one I've been using. Okay. Anything else? So everyone here is cool with variables through functions now, right? Okay, well, if you aren't, please let me know. So now we have some time for bonus stuff. I can start explaining how to read an API with a string class, or we can start going back and explaining what static is and why it's showing up everywhere. If you guys are having trouble setting up Java and JUnit on your machines, I can try to do that as well. And also, if you've already written some code, you can send it to me and I'll take a look at it and see if I can spot any mark clauses before you submit it. So, are there any preferences? If not, I will probably default to this because it's what everybody's been asking about, and I said that I mentioned it later. Yeah, okay, cool. Let's explain static. Which means I have to break out, go off script, and try and start doing some object-oriented programming things. So to understand static, you first have to, static and object-oriented programming, those go hand in hand. You can't understand static without understanding object-oriented programming. So basically, we have to take a step back from all of this now. Now that we know how to do things within methods, let's talk about how to organize these things as a whole to actually create things in Java. So first and foremost, Java is an object-oriented programming language. When you want to make something in Java, so like software or a game, you have to think about everything in terms of objects. So the example I used for my old lecture on object-oriented programming, which can be found at this link, which was provided to you when you downloaded the source code, is in terms of a game of a Pokemon game. So for example, you have a Pokemon Pikachu, right? Basically, every single Pikachu you see in the world is an object, and objects are created from classes. So classes are basically templates that can define and create objects. And then each of these templates can say that every single Pikachu needs to have a certain amount of health. Every single Pikachu also needs to have a type. And we also have a method in here. So in this case, we just have an attack method and that calls that. And here, we can just and this is the syntax for creating an object from a class. So we have this class Pikachu, and then we just want to make a new one. We can set an object's we can set an object's variables over here. So we have Pikachu, the health is 20, type is electric, and then we basically store these things inherent to the class. If we wanted to make a second one, we could do that and give them a different health and different type. But for now, I just want to show you that these are all associated with the class. Notice the lack of static. So let's actually go in here and give this a bit of a run, shall we? Show this in Explorer. Oh, not you. Remember, whenever you do the Java command, it has to go to a thing that has the public static void main. So let's see. We have a class Pikachu, and then we made it into an object over here, and then we gave that a bit of a run. Pikachu is an electric Pokemon, that checks out. We set that over here, and as 20 health, we set that here. And then we say Pikachu electric, it runs this class func method, and there we have it. Any questions so far? Cool. That means we can move on to static. So static, well, I'm just using the old code from last time, except I'm adding a new thing right now, and this is the integer attack count. And notice the use of static here. Static members can be accessed without an instance. So back in the old one, we made an instance by using the new keyword. We can actually access attack count without using that new keyword. So we don't need an instance to run this from. So yeah, when we say attack, we actually do attack count plus plus. And because attack count is associated with a class instead of an instance, this is going to be universal. So regardless of which Pikachu we call this from, all of that is all going to be, they all share the same attack count. That is all going to be incremented. This can be useful if you want to like implement statistics in or something. So let us go to so we all attack 4 times, and we see that attack count has been incremented 4 times and was not inherent to any of the Pikachu. So that is basically what static does. It makes things inherent to the class. And hopefully now you're starting to have a pretty good insight into why public static void main is the way it is. When we say Java runner in the terminal here, it goes to this class and it's looking for the main. But clearly the console doesn't want to create a new instance of the thing that it's running. So it's just going to call this without using an instance. It goes to the class directly, and then that is basically how the static and public static void main works. So the static starting to make sense to everyone now? Why do we have string args as an argument for main if we never use it? Remember when I talked about method signatures, like all the way back in here, I mentioned that even though we have 2 methods that have the same name but different parameters, they were able to be, the Java was able to distinguish between the two. This also means that when you try to run a class file in Java and it's looking for a public static void main, if you leave out the args, it's not actually able to find it anymore. Main method not found. So this is just inherent to the main method. The main method in Java, the entry point, the console will always be looking for the main, it being static, and the string args. And if you want to know how args is used, you can just sort of do run the class name, and then you can provide a few strings like A, B, C, D, and then we can print that out. So this is the first argument we are providing to this class file. Oh, I forgot to recompile everything. That is important. That is why I like doing this. Having them run in sequence. Index 0 out of bounds for length 0. Did I forget how to use arguments? I probably forgot how to use arguments. Basically, if you want to pass in arguments to your main function, you would use args to do it. I would have to search it up if I want to use it because I basically never use arguments. I always use just user input. I haven't ever had it. I don't know the last time I needed to use string arguments, but that is basically the purpose of it at least. For now, what you need to remember about it is that this is the signature that the console looks for whenever you're trying to run a class file, and that is how it finds it. Does that make sense? I should probably look at how to. Wait a minute. That looks perfect. That looks like the exact same thing I did. Oh, I'm an idiot because I didn't actually give it an argument. So here we go. I wasn't forgetting anything. I just didn't actually compile it. So yeah, Java runner, and then we pass in a single argument, ABC. It prints out that argument. There we go. Thank you, Java. Oh yeah, that was probably a bit small. Hopefully it's more visible now. Yeah, okay, cool. Do you not have to import files in the same folder? Oh yeah, you know what? Yeah, we're in extra bonus time now. I can go over this. Basically, if they're in the same Java, you don't have to import files if they're in the same folder. Yeah, if they're in different, if they are in a different package, or they're, for example, java.util, you will have to import that. But as long as everything is in the same folder, Java will attempt to link all the files there, and everyone is happy. So yeah, same folder, everything can see each other. Hopefully that makes sense. Cool. Anything else? If you want to see an explanation of all the rest of these topics, because I cannot cover this in 40 minutes, again, you can take a look at the lecture I hosted last year that goes over everything here at this link. But yeah, are there any other questions or any other requests for bonus time?
So as long as it's in one file, the code will work as a whole, like as a one.
Yep, as long as, even if everything is one file, everything is accessible, obviously. But if they are in the same folder, everything here can see each other as well. So I think later on I have something a bit more complicated. So here I have many different classes and they are all in the same folder. All of these files are able to see each other. So we have the main file here. It's able to access the Pikachu class here. It's able to access the Berry
So
class here.
it's like same thing as writing like a bunch of code in one file or one page.
In a sense, yes. But remember that the only thing that ever gets run is the main function in the class that you run this from. So this is the entry point for your program, and it is the only entry point. Even though you have all of these files, that is what gets run. But from this entry point, you have access to everything. And all of these files in the same folder also have access to everything. As long as they're in a different package, but you don't have to worry about packages for the entirety of this course, so I wouldn't worry about that.
Okay.
Yep, I hope that cleared things up.
Hey, I got a general course question if you don't mind, if you still remember
Yeah,
it.
go for it.
So for ITI one, for the Python course for ITI 1120, the course midterms were more heavily based on actually being able to code. But for the midterm for ITI, like the Java course, when I looked around online, I realized that most of the testing is based off like actual search algorithms for the exams. Was yours last year also a lot more based off of like actual logic and understanding of like the coding principles such as like binary search and whatnot, or is it more based on like the one in the Python course where it's more based off programming and you get a specific question that you have to program out of?
In response to, okay, I should just say that from the start, I haven't actually attended the Python course. I've basically been asking my friends who did come from the Python course for tips that they wanted to share with you guys and been repeating them. If Guak or if it wants to take that question about the Python exam, then sure. But for the Java exam, I want to say that the exam last year was an anomaly because the class was just really, really unforgiving for newcomers to the point where the average was like a 56. For the most part, it's basically testing your ability to code. Like I'm just popping open a new midterm right now from that looks a bit reasonable, and everything is just testing whether you can code. So I think it's pretty similar to the Python course from what it sounds like. And yeah, as long as you know how to code, you should be fine. The multiple choice question, there might be a few multiple choice questions that test your knowledge on just abstract object-oriented programming things. I don't think there's any in this one because this exam actually looks reasonable. For the most part, you're just going to be asked to code.
Okay, sounds good. Thank you.
Or at least that's
Also,
what I hope. Last year was an
yeah.
anomaly.
Also, another thing for the labs, Okay, let me see if I can open it up. Sorry, but during the labs, there's like this thing like when we're submitting, you have to create a directory. What is that specifically referring to? Like I'm so confused. Like here, hold
I
on, let
know
me see.
that creating a directory is basically the same thing as a directory is just the same thing as a folder. So if you want to create a new directory, it's just a new folder, and then you would name this to whatever the lab specifies that you need to name it to. You enter here, you put your code, and then you zip it up and you upload. Probably, I would have to like take a look at the
Oh, okay.
screenshot. Yeah,
Okay, what? Okay, they just like
yeah, directory is
overcomplicated
just the
it.
same thing as a folder.
Yeah, okay.
Any other questions? Well, this stuff is just. If not, I think we can probably wrap up the session, unless you guys want to see anything else here. Anomaly.
So did you knew Java like way before 11.21? That's why you're able to like pass with A+.
Probably, yeah. I had been using Java throughout high school, and I've made a few games in Java as well. So when I came here, I basically knew everything, and I just used that to handle the assignments. Basically, from my perspective, the assignments were at my level, but my level was someone who already knew Java. So that's probably why it was so difficult for everybody else.
Because like I'm new to Java and the lecture's already confusing. So I'm just
Oh no. I guess it might be the same this year then. Is this course always like this then? That's insane. At the very
think so.
least.
Like all the online reputation people are saying it's like 11.21 is not good. And like all my
I don't know what they're
my
doing.
professor's side is just all 1 out of 5, 1 out of 5. So
Yeah. Well, at the very least, that's like the main reason I wanted to make this session so that it'd be easier so that I would actually cover some of the stuff that the professors just magically expect you to know when you walk in their courses, like all of those really niche bugs with double division and whatnot. I basically made this in hopes of making things easier for everybody.
do you do these sessions like often, or is this just like one time thing?
Could you repeat that, please?